Hello, I Kiran Mudradi, Assistant Professor, Department of Computer Science and Engineering, Ballari Institute of Technology and Management, Ballari. Welcome you to yet another class of system modeling and simulation. In the last video lectures, we started module 3, that is random number generation. Here we begin with the continued part of the same module. In the last video lecture, we discussed Kolmogorov-Smirnov test. Here we go with the chi-square test. Both are used to check one of the key criteria for a random number is uniformity. The random numbers which are generated through the help of a linear congruential method or combined linear congruential method are uniformly distributed or not. To test that, we are using Kolmogorov-Smirnov test and chi-square test. In this video lecture, I begin with chi-square test. Let us go ahead with the chi-square test history. The chi-square distribution was introduced by German statistician Friedrich Robert Helmholtz. The chi-square test was first used by Karl Pearson in the year 1900. The most popular chi-square test is Pearson's chi-squared test, and it is also called chi-square test and is denoted by chi-square with this particular symbol. These are the two statisticians, Friedrich Robert Helmholtz and Karl Pearson, who created or discovered an algorithm to test the uniformity of random numbers. So I'll take you to the chi-square test, which are the formulas and how the algorithm is going to be used in the next slide. So let us understand chi-square test. Chi-square test uses the following two formulas. One is chi-square and EI. We need to calculate these two values. Okay. So here in the formula, chi-square is equals to summation of I equal to 1 to n OI minus EI whole square divided by EI, where OI is nothing but the observed number in the ith class, E stands for expected number in the ith class, N stands for number of classes. And through the help of with this formula EI, we are going to calculate N, capital N divided by lowercase letter n, where capital N stands for number of observations and lowercase n stands for classes. So you will understand these formulas while I am solving the problem related with the chi-square test. So first and foremost thing, we need to understand the algorithm to solve a problem. Okay. So chi-square test algorithm. So it constitutes 5 steps. The step 1 is for a given n. N is nothing but what? Number of observations. Okay. We need to calculate OI. OI stands for observed number. EI stands for expected number. And using this formula, second step, chi-square is going to be calculated. Okay. And we are going to compute in the step 3 degree of freedom, that is D is equals to n minus 1. N stands for classes, number of classes minus 1. In step 4, from a given alpha, in the problem statement, they will give alpha value. From the chi-square table, it is going to be used. And the degree of freedom D, a critical value is determined from the given chi-square table. In the examination also, they are going to give chi-square table if they asked you the problem on chi-square test. In the step 5, our job is to comparing with the calculated value in the step 2 chi-square with a critical value from the given table. In the step 4, we are going to observe or take or note down the critical value, and we are comparing both chi-square and the critical value. That is nothing but chi-square. If it is less than the critical value chi-square d comma a, then they are uniformly distributed. If this condition is true, then uniformly distributed, else not. So this algorithm is given by two uh, German statisticians, Friedrich Robert Helmut and Karl Pearson. So the same algorithm is applied and used to test for uniformity of random numbers. I'll take you to the example so that in a much better way you will understand the chi-square test algorithm. Quite simple. There is no integration. There is no differentiation. Quite simple arithmetic operations. That's all. Okay. So try to understand the example problem statement. Test the following number for uniformity by chi-square test. The numbers are given, some random numbers, 0.15, 0.22. Similarly, it goes ahead with 0.1.3 and 0.03. Totally, there are 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So n value is the capital N, that is n, number of classes. And the classes range from 0.00 to 0.10 to 0.90 to 1.0, that is also 10. So uppercase letter n equals to 10 and lowercase letter n equals to 10. You will come to understand. I'll make you in a much better way. I'll take you to the example while solving in step 2. So capital N is 10, total number of random numbers divided by number of classes. The classes in the sense I'll show you. Okay. So this is total numbers 1 to 10, and this is a classes. How I done a class 0.00 to 0.10. This is one class. Similarly, it goes with 0.10 to 0.20. This is second class. Similarly, it goes ahead with 0.90 to 1.00. Totally n classes. This is capital N. This is number of classes, lowercase letter n. So therefore, capital N is also 10, lowercase letter n is also 10. It is 10 divided by 10 is equals to 1. So we calculated in step 2 EI, expected number. Okay. How exactly we need to calculate OI? OI is nothing but, I'll take you to the second step at the time you come to understand. Look into this interval range, interval number. OI stands for observed number, expected number. Okay, observed expected number is always 1. We're expecting at least one number should be in this particular range, 0.00 to 0.10. At least one should be our expectation. But in the given random number, how many are there in that particular range? Okay, look into this. 0.09 is 1, 0.01 that is 2, 0.07 that is 3, 0.03. These are the four numbers are in this particular range. That means it begins with 0.00 to 0.10. So that is how many numbers that are in that range? 4. Similarly, you test it for 0.10 to 0.20. In the given random numbers, how many are present in that range? 0.15, 0.11 and 0.13. Totally 3 numbers are in that particular range. Similarly, you need to find out. Similarly, we got 0.20 to 0.30. So 0.22, 0.25 that is second, and 0.28, totally 3. So it is 3. And 0.30 to 0.40, no numbers are there, so I kept it 0 for all the remaining things. Totally we had 10 are already finished here. So expectation is what? At least we should have one number in that particular range. Our job is to calculate chi-square. If you want to calculate that, you need to use this formula. So divided the complete formula in two different ways. OI minus EI I am calculating, that is 4 minus 1 equal to 3, 3 minus 1 equal to 2, 3 minus 1 equal to 2, 0 minus 1 is equals to minus 1, and similarly this column is filled. And similarly I'm taking the square of this particular column. The square is 3 square is 9, 2 square is 4, 2 square is 4, minus 1 raised to square is 1. Similarly I'll fill this particular table. And OI minus EI whole square divided by EI. EI value is how much? Which is calculated in step 1, that is 1. So anything is divided by 1 remains same. So I completed this particular table. If I count it, I got the value 24, that is chi-square. Okay, so we got the answer 24. So now move ahead with step 3. So this is what chi-square is nothing but what we calculated is 24. So step 3 is we need to calculate degree of freedom. Degree of freedom, D is nothing but n minus 1, which is already told you in the algorithm. N minus 1. N value is how much? Lowercase letter n is 10. Minus 1 is 9. And alpha value is given in the problem statement. Alpha value, that is 0.05. For this value we need to calculate from a step 4. In step 4, alpha value is how much? 0.05, and D value is 9. So by referring this particular table, it will be given in the exam. So n value is D value is how much? It is 9. Alpha value is how much? 0.05. So this is alpha value, this is D value. When it is 9 and alpha value is 0.05, you trace it here, you will get 16.919. So my critical value is 16.19. I'm comparing it with a given value. Here it is not less than that, it is greater than. So therefore it is not uniformly distributed and the random numbers are rejected. If it is less than, it is going to be accepted, otherwise it is rejected. In this way we are going to solve a problem using chi-square test. We are going to verify the given random numbers are uniformly distributed or not. Similarly, you solve this example. I'll give it as an assignment. And before that, we need to understand what are the advantages of chi-square test over KS test. Both KS test and chi-square test are used for to check uniformity, but KS test is basically used for a small sample size, but chi-square test is used for large samples. In the previous video lecture you've seen a KS test, and in this lecture you gone with example large samples are used for KS test. Okay, this is one of the advantage of chi-square test over KS test. So copy this question, assignment question, and try to solve it using chi-square test. Namaskar, and thank you for watching.